All right, let's go ahead and get into Module 1, which is Communications in a Connected World. So I talked a little bit in the intro of kind of what the objectives are for this entire course, but specifically for this module, we're really just trying to get you to be able to explain the concept of a network. So if someone, like I always attribute it to like, if your grandma wants to know what a network is, how would you tell her? You know what I mean? I need you to, or, a fourth grader, how would you explain it to a fourth grader? Maybe someone that hasn't been around technology, how would you explain it to them? Okay, does that make sense? That's what our goal is by the end of this lecture. We're also going to talk about network data. We're going to talk about transmission speeds and capacity. When we're talking about megabits versus megabytes, like which is which, we'll be able to answer that question. And then also talk about different infrastructure devices that you might run into. So let's first get started with network types. So first and foremost, everything is online. If the pandemic didn't teach us anything else, it was that we could do a lot of our jobs from the comfort of our home. And the reason that we were able to do that is because everything is online. This presentation that I'm doing right now, it lives online, in Google Sheets. When I'm done with this recording, it's going to be online. The tool I use is called Loom, and it'll be there. So again, everything is online. Everything that we do, everything that we interact with is online. Okay, so with that, they need people like us, they meaning the rest of the non-techie folks out there, they need people like us to make sure that those things stay up and running. So whether you're going into IT, whether you're going into engineering, cybersecurity, whatever that is, we still need you. We need to make sure everything can stay online, okay? Because everything does live on the internet. So one question that, I pose to my students is, who owns the internet? Like, is it a place that we go? Like, is it, in the middle of the U.S., is there a big data center and it holds the internet? Is it like Disney theme parks where you can just go through the gates of the internet and there you are? And no, it's not that at all. The internet is, to boil it down, it's basically a bunch of computers that are talking. They're talking from different states, different countries, different continents even, and it's basically a computer or a server that is living in a data center somewhere. And a data center is basically just big buildings that have a bunch of cooling and electricity and stuff, and they hold servers. And we just talk to those servers. We use our web browser, and we will send requests, and then those servers will serve up information, or they will send us information back. So the definition of internet is, the internet is a worldwide collection of interconnected networks. So like I said, it's just a bunch of computers, and we talk to those computers from all over the place, okay? And even your home, you could actually set up a server at home, and you can be part of the internet. You can make it a mail server, you can make it a web server if you want to host your own website. You can be part of the internet, if you will, by putting that server at your house, okay? So when we're talking about our home networks, we would refer to those as our home networks, when it comes to local networks. Or if you have a maybe just a little bit bigger, would be a small office or a home office. Okay, so let's say, for example, the accountant that does my taxes, it's a home office, but there's, I want to say 8 people that work there. They just did an addition. So, that would fall under that kind of small office, home office kind of network size. Okay, and it's important to understand kind of these different sizes of these networks when you're first getting started, because as you learn a little bit more about networking, like I had mentioned in the kind of overview video, we'll start talking about scalability. If it's your local network at home, do you really have to think about scaling as much? Like, are you going to have to put a 48 port PoE switch in there? Well, with a new house, I would argue, yeah. Like, if my wife and I were going to build a brand new house, I would probably put a 48 port PoE in there, because I know I'm a techie and I'm going to run, I want PoE in every room in my house, because who knows, as far as future proofing. But If it's just your home now, maybe most of everything that you do is wireless, or maybe you don't even have home internet because you just use your cell phone all the time, and that's okay. But when it comes to learning networking, you just have to know when you're designing the network, as far as scalability, like how much scalability are you going to have to have. So the smallest is going to be your small net, your home network, and then from there it goes to small office, home office. Okay. So now we're going to take it a step further. So now maybe we are going to go to a school, for example. We're in a school here where I'm recording. That would be what you would consider a medium to large network. So with medium to large, you're probably going to have a couple switch closets. You could probably start dabbling into kind of a hierarchical approach, if you will, because you might be adding on in the future. Okay, so I can say here we have, I want to say like 5 or 6 different closets in this building that have switches and whatnot. So that way, if we need to add on more, we have that area to do it, and we can kind of scale out from there. And then from there, from medium to large, then we move to kind of a worldwide network, okay? So for example, my mom works for a worldwide corporation, a very large corporation. So they have, 20 or 30 sites here in the US, but then they have probably 50 to 100 other sites around the world. So with that, it would be a kind of a worldwide network because, there's stuff in Germany, there's stuff here in the US, there's stuff in Canada, and they all connect. They have to be able to talk to each other. So, through a series of, VPNs and, routing, all that stuff can kind of talk, and they're able to access access the resources that they need. Okay. So we've talked about the actual networks themselves, but what about, those are the roads of the internet. So what about the cars that run on those roads? What kind of things can you expect to see? Well, this list, I swear, is getting larger and larger every day. I've seen connected toasters, these lights even that I'm using here in this little closet that I record in. Those have the ability to connect to a network. Everything is being connected. I'm looking over and I see, a PS2, a PS3. I see a camera. Even this is a Fuji camera. It has the ability to connect as well. So, these devices can come in a myriad of different form factors. Okay. I'm even thinking like stuff for my son. Like we have a camera, over his crib, kind of a new age baby monitor, if you will, and that connects to the internet. Our home security connects to the internet. So these are all devices that, as an IT person, you are going to have to know how to troubleshoot or how they should work. But also, as a cybersecurity professional, you're going to need to know and be aware of kind of the vulnerabilities that come with those things. But let's go through a couple of the more common ones that you are going to run into. So first and foremost is mobile devices. These are very ubiquitous. Smartphones are absolutely everywhere. This is kind of our all-in-one device that we interact with kind of on a daily basis, and our users interact with on a daily basis. From there, tablets, they're basically bigger phones. A lot of them don't have the actual, LTE chips in them or 5G chips in them, but they are going to be similar to, a laptop. You'll see kind of hybrids nowadays, but tablets are also, things that are going to be, connecting to your network. Other things would be, this kind of died, but Google Glass. But even taking Google Glass out, just wearables, with whether that's Fitbits. I've seen connected rings before. I know Bose has like Bluetooth eyeglasses. These are all kind of wearables that some of those need to actually connect to your network as well. So again, the amount of these devices is growing, and like I already said, cameras and connected household appliances. So, that crock pot that connects to the Wi-Fi, well, is it great that your roast is done on time? Yeah, absolutely, but it's also another thing that you have to update and patch and make sure that a hacker can't access it. So, it's our responsibility to make sure that we are securing these devices, but in order to do that, you kind of have to crawl before you walk, and that is you have to understand how they're communicating on the network in order to safeguard your network against those devices. So RFID, we'll talk about this in a later episode or another video. RFID is radio frequency identification. So this is less about networks per se, but these devices will interact with your network. And what happens is these little things that you see here, they can be used for two things, two main things. One is for inventory purposes. So if I wanted to track this camera, I can put like a little RFID tag on it, and then readers like at every exit of the building so I know when it leaves the building. You could also use these for badges, like to badge into a building. And what's cool about this is these lay dormant, meaning they don't have any charge on them, but the reader is emitting electricity. So as it comes closer, it's going to activate what you see here on the screen, and it's going to talk to the reader. So although it's not necessarily connected to the network, these physical wires here, that reader will be connected to your network. So that's what's going to allow you to badge in and badge out, because it's going to talk to your authentication server in order to open that door or give access to that user. So these are kind of at the edge of the connected devices. These are things that are more kind of specific uses, like you can see here, connected sensors as far as plants growing and whatnot, and also if you're working in or going towards hospital IT, there's plenty of. I forget someone that I'm actually on we have like a local IT group meetup, and it's basically like smart home devices, but for hospitals. Like they have their own kind of connected healthcare type of devices that are out there that he was talking about how they have to constantly make sure they're being secured, especially with that patient data. So let's talk a little bit about types of data. So just to review, we've talked about the networks themselves, the different sizes of those. So that would be like our roads. We then talked about our cars or our vehicles that are on these roads in the form of mobile devices, tablets, laptops, computers, connected devices. But now we're talking about what's actually inside those vehicles, okay? So in this case, it's going to be types of personal data. So data is what moves back and forth on the internet. So we're going to use our computers in order to access that server that's in that data center, or we are going to access that service that's available, like Spotify, things like that, okay? So when we talk about data, there's three main types of data when it comes to personal data. There's volunteer data. So this is created and shared by individuals. This is stuff that you can find like on social network profiles or pictures, stuff like that. Once you get into cybersecurity, you're going to learn a little bit about OSINT, or open source intelligence gathering. That's where we're going to use this data as far as kind of creating our attack for penetration testing and stuff like that. Observed data is going to be data that is captured by recording. So whenever you download an app, you probably have to accept permissions, specific like location permissions or something about data. So with that location, that's going to be observed data. So we can look at that location data and start making educated guesses on where that person was, and that's where big data also comes in. And then there's infer data. Infer data is going to be things like credit score, which is based on the analysis of the two types of data that are there. So both volunteered and observed data. So this data, now that we've talked about like what's in those cars, let's break that down a little bit further, and that is with bits, okay? So computers, and you should have learned this in your IT fundamentals or your A+, and if not, that's totally fine. But computers only work in zeros and ones, okay? So even like if you learn a little bit about coding like C and C#, computers still don't understand that. Like it has to be converted into a language that the processor can, kind of chew on, and that is zeros and ones, okay? So with that, either a 0 or a 1 is going to be called, or you would refer to that as a binary digit. And that's the smallest piece of data that we're going to interact with. And we're going to put a bunch of those zeros and ones together in order to move data around on a network, okay? And then when you put 8 of those together, it's going to be called a byte, okay? So bit is 1. It's a 0 or a 1. And if we put 8 of those together, that is going to be a byte. And if you're taking notes, I would definitely be writing this part down. This is going to be super important, and it's something that you're going to use throughout the rest of this course. Okay, so now to get from those bits and those bytes, we want to make it kind of human readable. We have this thing called ASCII, and if you've been, many of you are digital natives, so you've seen things like ASCII art, which is where the different characters come together to create kind of like a mural or a picture of some sort, and that ASCII translation is represented by 8 bits. So you can see here the capital letter A is equal to 0, 1, 0, 0, 0, 0, 1. The number 9 is 0, 0, 1, 1, 1, 0, 0, 1. And then, the special character, which is a hash sign, is 0, 0, 1, 0, 0, 0, 1, 1. So this will actually translate from those characters that we're used to like writing and typing and stuff like that. And if it's in ASCII, you can actually convert it to zeros and ones in order to translate it to something the computer can understand. So if you're in my course, when you're going through the modules, you'll actually have part of the guided notes is to use an ASCII translator and type in some stuff. So if you're not in my class, jump online, pause the video here, jump online, and go play around with translating. Like translate your name, translate your favorite character from a book or a movie, and see kind of how that translates over to zeros and ones, or vice versa. Like type in a bunch of zeros and ones, 8 at a time, and see what you can come up with. I'll wait. Are you done with that? Okay, let's go ahead and move on. Hopefully that was a cool experience that you can see how you can convert those two different things. So how do we move this data around? Well, there's 3 main ways that we can actually move these bits and bytes across our network, or across the WAN, the wide area network, which is across the world. The first way that we do it is with electrical signals. So these are actual pulses, electronic pulses that are on copper wire, and it's that on, off, on, off, on, off. It's going to send those pulses on the wire itself. And I don't know if you remember from the overview, we're going to talk about making our own cable that is, that uses copper. It's called UTP in order to move those pulses of electricity on our network. Okay. From there, we move on to our pulses of light. That's going to be in the form of fiber optic cable. And basically it's like we take a tube and we put a flashlight at the end and we turn it on and off, on and off, on and off, and that goes through. Now, it's not a flashlight. It's usually, lasers and really powerful stuff, but we do that and it's able to send that data very far. With copper and electricity, due to physics, you're going to actually lose a lot of that as it's going through the wire, whereas with the fiber, you can go a lot longer distance. Sometimes, it's not possible to run fiber, or it's not possible to run, especially in really rural areas, to run copper or fiber. And that's where wireless signals come in, or like I've done in the past, I've set up wireless signals for if we put a modular up at a building, I'll just throw a wireless point-to-point, and I'll just use wireless signals kind of back and forth using microwaves or radio waves, and I'll send that data that way. Because instead of, going down under a road and then up when there's only going to be 2 or 3 people maybe in that modular, I just ended up throwing a point-to-point in there, and we're good to go. Especially, I even put a wireless point-to-point at my parents' house, to get out to their barn. Instead of us digging a trench and going out there, I just put a wireless point-to-point up, and they just kind of talk back and forth, if that makes sense. So those are kind of the 3 main ways that you're able to move data across the networks, or gain access to those networks. So now that we've talked about how to move that data, or what that data moves on, we're going to talk about 2 very important things when it comes to data transmission, and that is bandwidth, excuse me, and throughput. Okay. Now, again, this is the part where if you're taking notes, which you should be, those are 2 words that I want you to write down on your notebook, because it's important that you know the difference between these 2 things. So bandwidth is how much data whatever the medium can carry is, okay? So think of it like our roads, okay? So how many, we're talking about capacity here. So how much bandwidth, or how much, how wide is that band for us to be able to move data across it? Okay, so is this a 5-lane highway? Is this a 2-lane highway? Like, what is the width of the band that we're working on? And I want to pause here and make a point, because I just separated a word to help you understand it. That's something that I tell my students all the time. Like, if it's a new word, kind of use your context clues to kind of figure out what it might mean. Okay, so bandwidth. Well, I know that word width means how wide something is. I wonder what band means, so I can look that up and then put it together to help you kind of understand that. So in this case, it's like the roads going into a city. Is it a 10-lane road going into the city, or is it a 1-lane road? How many cars are able to go through there? And for this, we use bits per second. Notice it is not, we are not using our, we're not saying like megabytes. We're using the actual bits as our smallest one, that BPS. So you can see there the lowercase b on there is megabits per second, okay? And then as we go down here, we'll see that it has the millions of bits per second. That is our megabits per second. If we have 1 billion bits per second, it's gigabits per second. If it is, trillions, that's going to be terabits per second. And you'll see what that equivalent is here on the right-hand side. So we start off with just bits per second, and then kilobits per second, megabits per second, gigabits per second, terabits per second. Okay. From there, we go to our actual throughput. Now, throughput is the amount of data that can be sent and received over that connection. Okay. And something that you'll also hear here is latency, or like if you're a gamer, what's your ping? That's going to be how much time it takes to get from one point to another. Okay. So throughput is going to be measuring how much data can go across something over a period of time. Okay. So when you're purchasing your internet, you're going to be purchasing it based on the actual throughput of that connection. Is it a 100 megabit connection? Is it a 2000 terabit connection? Whatever that is, that's what you're paying for. And it's going to be up to that amount of speed is what you're doing. So if you do have any questions on that, or you need me to clarify it, or any of these concepts anymore, please reach out, tj@tjhouston.com, and I'll be able to answer any questions or clear that up for you. That's where I see a lot of people kind of get mixed up, is bandwidth, which is, how wide, coming through, and then the actual throughput is the measurement of how much data is actually coming across that line. So from there, we're going to go to clients and servers. So a lot of times people, kind of throw that server word around. Oh yeah, I connected to that server, blah, blah, but what is the role of a server, and how is that different than a client? Because technically my iPad can be a server. When I went to Cuba and did some training down there, I used my iPad to serve up a ton of files. I used it to serve up, different resources for them to use, different tools and whatnot that I had built. So they were able to, access my iPad because it was acting as a server. So what you might look at as a client or a consumption device, it can also be a server. So I want to break this down a little bit for us. So the biggest difference between the two is the software that is installed. Okay, a client is going to be a device that is trying to consume or trying to make requests to the server, whereas the server is going to host that information and share it with the different clients. Okay, so if you think of it like you are a customer at a restaurant or a client at a restaurant, you are sitting there. You make a request for, I want this food, I want this salad, and then the server will bring it out to you. It'll serve that up to you. Okay, so some of the examples of the main ones are email servers and email clients. So again, the email server is going to run the serving software. It's going to serve up that service, whereas the client is going to make a request. So in this example, using Microsoft, the server would be something like Microsoft Exchange, and then the client software would be something like Outlook. It's going to use Outlook in order to make that request. It's going to say, hey, I need that email, send it to me. show me what that is here. Okay. A couple other ones would be like file servers, which are just, again, music, movies, pictures, whatever that looks like, or web servers, and that's going to host things like websites and whatnot. So when we're talking about different networks, there's different types of networks, okay? Types of communication that you can have with this kind of client and server. You can have just a client-server network, so the client makes the request like we saw on the last slide, but you can also have peer-to-peer networks. So you primarily see peer-to-peer networks on small offices where there's might only be like 3 or 4 devices in this small like medical building or like the dentist's office, if you will, where you'll have one computer, maybe the secretary's computer, and she has the printer physically connected via USB, and then she right-clicks on it and she clicks share on the network. Well, now she has just become the print server, and she normally does her normal stuff, but behind the scenes she's kind of acting as that print server. And maybe another server, maybe the dentist's server or the dentist's computer, he's going to act as a file server. He creates a folder on his hard drive and then right-clicks on it and shares it out to the network, and now we have this kind of peer-to-peer functionality. So P2P is a peer-to-peer network, super easy to set up, great for simple tasks, but what would happen if tomorrow they decided to add, 5 more dentists and 10 more clients, and they're doing a bunch of paperwork? Well, that's really going to bog down that secretary's computer, and having all these other dentists try to access this one dentist it's just not going to be a very good situation. So it's at that point that you're going to want to look at more of a client-server network and less of a P2P, because there's not really great central administration. It's not scalable. Slowing performance is another thing. So again, there's a time and a place. And honestly, your home network, it might be just easier for you to share your printer from your computer. If you have that desktop at home, because there's maybe 3 or 4 people that might use it, and the chances of them using it all at the same time is slim to none, and it just makes sense. Like, don't invest in a print server, for your home or your home printing use. But for example, like that, the accounting service that does my taxes and whatnot, it probably makes sense for them to not use this P2P network, because they have 6 or 8 people that could very well need to print at the same time, and they're very large files. So, in that case, it probably makes more sense for them to move out of a P2P network and into a client server. There's also this idea of peer-to-peer applications. So think of it like walkie-talkies, where they send data back and forth. So it's not just a networking thing with peer-to-peer. It's also, applications can do this as well, and they kind of run this little service in the background that acts as a client and a server. And one of my students actually this year built this exact thing in Python. He made an encrypted chat service that he could talk back and forth, and the device was both a client and a server, because it was requesting data from this person, and then it was also serving up data so they could talk back and forth. So you can have it for applications as well. So what are the different roles that you can play? And I get this question a lot, like, oh, Mr. Houston, like, do I have to set up one file server, and then do I have to set up, a web server, and then if I want to do printing, can I do a print server? And the answer is no. It all depends on, there's a lot of factors that actually go into it, but it all goes down to, capacity and also budget, manageability. There's a lot of things that go into answering that question, but you could have one server that is the email server, the web server, and the file server, and maybe even the phone server. It could be a big, beefy machine in order to host all these things, or it could be one server that is and we'll get into this in the future, but maybe it's virtualized, and you're running 5 different instances of Windows Server on that machine, and they all do different things. It all depends on how the devices are going to be used, or how those services will need to be accessed. Okay, so that's a whole nother, when you're starting to design networks, that's where you answer those. But just, I want you to be aware that, one server can be a file, email, web server. All these things can run just on one device. So when we are looking at network infrastructure, there are a couple symbols that you're going to have to be aware of. So if I were you right now, I would take a screenshot of this page right here. I'll do a cool thumbs up. Okay. So these are some of the most common things that you're going to see on a network diagram, especially if you take over somewhere. You understanding these little icons will help you understand kind of how the network works. So let's start at the top and work our way down. These are pretty self-explanatory, desktop computer, laptop, printer. This one might be new for you, a telepresence endpoint. So this would be like your conference room might have communication devices, more than just like an IP phone. It might have a camera, stuff like that, and also wireless wireless tablet. So, or like an iPad or whatever that looks like. These are all your kind of end user devices or endpoints. Okay, in the middle we have our different devices that kind of show kind of how data moves on the network. And what I mean by that is, switches you'll learn are layer 2 devices unless it's noted. Routers are our layer 3 devices, and that's what allows us to get to other networks. So key thing here is you'll notice that on a switch, the arrows go, just to like either north and south or east and west, whereas on a router they'll go kind of every direction. Okay, and the biggest difference between these two: regular router, this is a wireless router, it has the antennas. Again, I feel like that's pretty self-explanatory. You'll notice here we have a multi-layer switch, and those they also go, not just north and south, not just east and west, but every direction, and that's indicating that it can, operate at those higher levels. So those that like layer 3, for example, it can do IP routing. And then we have our firewall appliance here. So moving on, remember a couple slides ago we talked about the different media. So this is how you indicate wireless. So if we had a point-to-point, we would do these little squiggly lines. If it's the LAN media, then it's just going to be solid. Or if it's WAN, so like let's say it's us connecting up to our ISP or our internet service provider, we would indicate it with kind of this lightning bolt that you see here. It is important that you know those different icons for you as someone that's going to be documenting networks. You're going to build diagrams similar to this one, especially when you do new builds. But also, like I said, when you take over for someone, these are kind of like your blueprints on how the network works. We just talked about all those, but this is kind of an example. And as a exercise, I would highly suggest there is a lab that goes with this first module, and that is kind of documenting your home network. So I would definitely urge you to use a tool like Visio. There's also a bunch of free online ones. You could just go and get these images and copy them into something free like Google Drawings and draw out your home network and kind of get an idea for how everything connects together. Just for you from a documentation point, you can put like IP addresses and stuff by your wireless router or your printer, and just kind of have a nice display of what you have at your home network. So like I mentioned, you do have a lab assignment for this module. Record all the different network attached devices in your home, or we can also do it in the classroom, and investigate how each device connects to the network. How does it send and receive information? So if it's a printer, what does it connect to? Does it connect to a switch? Does it connect directly to a computer and then it's shared on the network? How does all that stuff kind of go together? You're going to create a diagram showing your topology. So this might be a new word for you. Topology is just a visual representation of how your network is set up. So it's like that one kind of a few slides back. This here would be an example of a topology. And then label each device with the function. And then I would even say add the IP address to it. So if you don't know how to get the IP address, that's fine. This is something that you can revisit as you're learning more about networking. You'll be able to revisit that and kind of make those updates to it. Okay, so these are the things that I hope you learned in this module. Okay, and if you don't have a good understanding of these, you might have to go back and watch that section over again, or you might have to. There's some other videos that I suggest in order to, understand some of these concepts. So first and foremost, the internet is a worldwide collection of interconnected networks that cooperate to each other and exchange information using common standards. That's the book definition. Basically, the internet is a series of computers that we talk to, whether those are servers or clients or P2B. It's basically a collection of things that are interconnected. That means they can all kind of talk using the different methods that we talked about. Some of the types of networks that you might run into would be a small home, small office, home office, medium to large, or worldwide networks. Some of the devices, specific like mobile devices, include smartphones, tablets, smartwatches, smart glasses. Some of the connected home devices that you'll see would be like our smart appliances, our TVs, gaming consoles, security systems. Those kind of all fall under that mobile devices, that connected home devices. And then you also have more specialized things, other specialized connected devices. And this is where I talked about that example for healthcare hospitals. Could be RFID, whether that's for inventorying or for door access. Medical devices, like I just said. Those would all be other connected devices. Maybe not in that home category, the home, subsection. These are more that wider category. Each bit can only have one of two possible values, and that's a 0 or a 1. And when you put 8 of those bits together, it becomes a byte. Okay, so that should be in your notes. There are 3 common methods of moving those bits around, and that is through electrical signals using copper or using like a network cable that you're used to seeing. There is optical signals, and that's going to be your fiber. Then there's wireless signals, which is like your Wi-Fi or your wireless point-to-point. As far as measuring the number of bits that could theoretically be sent across the media is your bandwidth. So that is kind of how wide that network is. And then the actual amount of data that is sent across that's your throughput. Like how much data can go through that, or how many cars can actually go through that, 10-lane highway, if you will. And with that, just remember there's a lot of factors that kind of go into, that throughput. How many users are on the network? What is the throughput of, what you're actually connecting to on the other side? Those are all things that can change the actual amount of data that you are seeing. Then we talked a little bit about that relationship of client and server. And remember that clients are hosts that have installed software that allows them to communicate or make requests to a server. And then the converse to that, or the opposite of that, is servers have software that allows them to serve that data up. And sometimes you have a machine that does both of those things for you. And that would be your P2P. So it's a client. It has client and server software on it, in that it's sharing out a resource like files or a printer. Anything else you need to know? The network infrastructure contains 3 main categories. So it's going to be end devices, intermediate devices, and network media. Remember that's the little icons that I showed you up on the screen that shows PCs, on PCs, tablets, telepresence devices. Those are all in your end user devices or end devices. Your intermediate devices is going to be kind of that next step down with like your router and firewall. And then network media is going to be, if you remember, like the little squiggly lines for wireless, the solid black line for LAN, or the lightning bolt, sideways lightning bolt for your WAN connection, or going over the internet outside of your local area network. And if I didn't tell you that, LAN stands for local area network, which is everything kind of on this side of what you would think of like your home wireless cable modem. Everything on this side is going to be your LAN. Everything on the outside of that is going to be the WAN, or the wide area network. Okay. From there, network devices that are most familiar with people are called end devices or hosts. Yeah, this is what people interface with on a daily basis. So if you are in my class, we are going to be creating a Kahoot based on these terms here. If you are studying kind of on your own, I urge you to take these words. I'll wait. I'll do my screenshot thumbs up. And with that, I would definitely create a Quizlet from these and kind of get to knowing or memorizing these these words and what they mean and kind of have a firm understanding of them. That's going to help you on your certification. So with that, I will open it up. Any questions that you have, please feel free to put it in the comments below, ask me in class, or shoot me an email at tj@tjhouston.com. Thank you so much for watching, and have a good day.